So I want to make sure these notes stay pretty short, but I want to give you as best of an introduction as I can to proofs. So on page 57, we're going to do intro to proofs. So let's look at page 57 on 1130. Our objective is to create logical proofs to justify geometric ideas. And this objective isn't really specific because it's one that we're going to kind of come back to throughout the year, because proofs never really go away. So to get started, we need to know some different types of proofs. And I don't know where my green marker went. Oh, there's my green marker. So we need to know some properties that are going to help us out. The first property that we need to know is the reflexive property. Like reflex, like you hit your knee, reflexive property. Okay? And what the reflexive property says is that anything is equal to itself. So BC is congruent to BC by the reflexive property. Okay. The transitive property says if so we use the transitive property when we talk about congruent. Used when talking about congruence or equality. So if x is equal to y and y is equal to z, then x equals z. This is also known as the chain rule because the y and the y's kind of chain up here, and since they're both equal to y, they're equal to each other. We can also use substitution to do the same thing, but substitution, so we could also, but the reason why we can't use substitution all the time is because if I was talking about angles, say angle A is congruent to angle B and angle B is congruent to angle C, then angle A is congruent to angle C by the transitive property. So the transitive property works for equality and congruence. Substitution only works for equality. Okay, so if I were to say x equals y and y equals z, then x equals z. That's also substitution. I could also use substitution in saying if x equals y and y plus 1 equals 2, then x plus 1 equals 2. But I can only use this substitution in equality when I'm talking about values. Okay, so the transitive property works all the time when I'm just doing this. The substitution only works in equals, but it means that I can plug in one value in for another as well. All right, so when we write proofs, we're going to kind of set them up in the same way every time. And we can write proofs in sentences, but we're going to start by writing proofs using a chart. So statement, reason. Okay, and I'm going to show you one proof first so that you come into tomorrow's class with one proof. So let's look at proof 1A. Okay, so in proof 1A, when we start to write a proof, we always start with givens. So we always write our givens first. Always first. So I always number my steps. So step 1 is to state my given. Step 1, angle B is congruent to angle E, and CB is congruent to DE. And why is that? That is given. So all I did was I took my givens and I wrote them here. And the reason for them being that is because it's what's given to me. My last step, and I don't know what number it'll end up being, but my last step will be what I'm trying to prove. So triangle EAD is congruent to triangle BAC. And I already kind of went over this in class. We know they're congruent by angle, angle, side congruence. So when I'm looking up here, I know I need to prove a pair of angles congruent that I have, and another pair of angles congruent, and a pair of sides. Well, I have the sides up here in my given. So I need to prove one other pair of angles congruent, and I had these marked down here. Okay? So I'm going to say that in my statement. I'm going to say angle EAD is congruent to angle BAC. And notice I'm using 3 letters to describe the 2 angles that are here because there's 2 angles at the same point. Okay. Why were these 2 angles congruent? Well, they were congruent because vertical angles are congruent. So there's my extra A. So now I have all the facts that I need to use angle, angle, side congruence. Angle, angle, side congruence. So now I can have this be my next step. Whatever I write down, I always have to have something to support it before. So I couldn't write this down before step 2 because I didn't have all 3 of the criteria proven yet. All right, I'm going to end there. Come to class with this. We'll have one proof done, and we'll do more proofs in class.